find rational zeros, aka we are going to find solutions to problems that are cubes or quartics and use some of the algebra that you've learned recently in this unit and in previous units to find these different answers. We're going to look at two different things here in this video. The first we're going to spend a short time on, which is what I call the old school way of trying to find rational zeros, which would require lots of plugging and chugging, lots of guess and check. It's not really a method we're going to use very much of, but something that I do want to show you briefly how you could use it. And then we'll take the majority of the time here to use the graphing calculator to help figure out and find these answers. So, the very top here, we're going to talk about what's called the rational zero theorem. So there are a lot of symbols and subscripts and superscripts here in that first statement, but here's the general gist. If you have a function that has integer coefficients, so there's no fractions in it, no decimals, no weird numbers, you can find the possible solutions by being able to identify two things. Finding the factors of the constant term and the factors of the leading coefficient, and dividing each of those together. What you end up with is a list of different values that could possibly work. It doesn't mean all the numbers work, but it means some of them absolutely could. It's basically a smarter way to guess and check. So in these two examples here, we're going to look at the possible rational zeros that you could possibly solve for and would possibly work in these problems. So in function, the example for A here, the function is f of x equals x cubed plus 2x squared minus 11x plus 12. First thing we need to identify is what's the constant, what's the leading coefficient. Remember that the constant is the term without the variable. So in this case, it's 12, while the leading coefficient is the number in front of the term with the highest exponent, stuck in that invisible one so you can see it. But those are the two numbers that we need to work with. Now, ultimately, we are trying to figure out the factors of each of those. So according to what's up at the top here, we're going to find the factors of the constant and compare them to the factors of the leading coefficient. So the factors of 12, there are three pairs, so a total of 6 numbers. The factors of 12 would be 1 and 12, 2 and 6, and lastly 3 and 4. Each of those has a plus minus sign with it because, yes, you could do 1 times 12 and get 12, but you could also do negative 1 times negative 12 and also get 12. So we are going to incorporate the plus minus sign with these here because there are both the positive and negative possibilities. Leading coefficient is a little bit easier because the leading coefficient is 1. The only factor is 1, plus and minus 1 to be specific. So what you would do here is you would take every number from the top, every number on the bottom, and you would divide them and simplify to come up with your list of possibilities. What makes this, again, a little bit simpler is there's only one value to divide by, that plus minus 1. All those numbers from the top would get divided by 1, so really not a whole lot's going to change because dividing by 1 we know doesn't do anything. So your possibilities would be plus and minus 1, plus and minus 12, plus and minus 2, plus and minus 6, plus minus 3, and plus minus 4. That means there are 12 possibilities that you could plug in. Only some of them work to find what the zeros would be, to find the actual solutions to this problem. In the olden days, before graphing calculators, you would have to try to basically plug these in until you could get at least something to work before you could chip away at it using other algebra skills. But those would be the things you would try to guess from. B, we're going to see the same thing here. We're going to identify the constant and leading coefficient. The constant is negative 10. The leading coefficient is 4. We're going to identify the factors of each of these. So the factors for the constant, even though it's a negative 10, we're still going to just work with it like it's a regular 10. The negative doesn't really affect this. So the pairs of factors that work for 10, you'd have plus minus 1 and plus minus 10. And you'd also have plus minus 2 and 5. My leading coefficient is 4. There are a couple more factors with it, so you'd have 1 and 4, as well as 2 and 2. I only write the 2 once because writing it twice doesn't really do us any good. You end up dividing by 2 multiple times, you end up with the same set of answers, so why be redundant? Now, to simplify these, you have to take every number up top and divide it with every number at the bottom. So I'm going to take the plus minus 1 and divide it by the 3 numbers in the bottom. So 1 divided by 1 is 1, 1 over 4, 1 over 2, and all these receiving the plus minus sign. You then do it with the 10 up top, divided with all the numbers in the bottom. So you end up with 10, 5 over 2, and 5. 10 divided by 1 being 10, 10 divided by 4 being 5 halves, and 10 over 2 being 5. Then I take it with the 2 and divide it. So 2 divided by 1 is 2. But then as I go through the rest of the list, 2 divided by 4 is 1/2. I already have that in my list, so I don't need to be redundant. And 2 divided by 2 is 1. I already have that in my list, so I don't need to list it again. Then last but not least, I divide the 5. 5 divided by 1 is 5, which by accident I wrote again. You don't need to list it twice by any means. Okay. 5 over 4, that's a new number in your list. And 5 over 2, we already have. That list, that's 16 total numbers that you can walk through. Those 16 numbers are your possibilities for solutions in this problem. And again, only a handful of them work. So you'd really have to possibly do a lot of guess and check and a lot of plug and chug to figure out what numbers work and what don't. That's a very lengthy exercise. You can certainly do it this way, but why would you? What we're going to do is a little bit shorter of a way. Since you have a graphing calculator, we're going to use it along with the algebra you've learned over the last few weeks to find all the solutions to these bigger problems. So let's take a look here at the next slide. And for this, we are going to use our graphing calculator. So I'm going to go ahead and pull that up on the screen here. So you can see in number 2, I've already punched it in. And with the graphing calculator here, I punched in our function x cubed minus 8x squared plus 11x plus 10. If you want to look at the graph of this, you certainly can. But what I care more about are the table of values. So once you punch this in, you hit second, graph. I didn't see the pop-up. Let's try that again. Second, graph. There we go. And that'll pull up the table of values. If you punch this in correctly, you should see a table that matches mine. Now, what you are looking for here, the calculator will be your friend in some respect in that it'll give you potentially some of the answers that you need for this problem. Sometimes it will give you all of them, but a lot of times it won't give you all of them. So we have to still use our algebra skills to solve for every possible answer, but we can certainly use the calculator to get ourselves started. So what you're looking for in your table is you're looking for at least 1 0, okay? One of the zeros. And remember, 0 is a word for x-intercept, aka the y value is 0. So if I scroll through my table a little bit, the first one I see, -1 comma 0, that is a 0 of the function. And again, key being, it's an x-intercept. The y value is 0. We are going to use that to get this problem started. So I'm going to go ahead and pull this screen back up. First thing you're going to do is you're going to use the calculator to identify at least one of the zeros. So in this case, -1 comma 0, we pulled that from our table. What we're going to do from here is we're going to use synthetic division to trim this problem down and to make it something that we can actually solve. Okay, so to use synthetic division, we're going to go ahead and take that 0 we just identified, the -1, and we are going to go ahead and put it in a little elbow box here. And then next to it, we're going to put out all the coefficients that are from that function. So the 1 off the x cubed, -8 from the x squared, 11 from the x, and the 20 at the end. You do want to check and make sure that you don't need any placeholders, because if you do need a placeholder and forget to stick it in, you're not going to get anywhere with this problem and you're going to have a massive issue. From here, it's the same process you've gone over the last couple of lessons with synthetic division. We're going to pull down the first number, we multiply by what's in the box, and add the column. Take that result, multiply by what's in the box, add the column, multiply, and add. If you do this correctly, this is kind of similar to when we did these problems when we had the factoring aspect of it. In factoring, it divided evenly. Well, if I have a 0, that comes from a factor, which means it also divides in evenly, meaning you should have no remainder. So the fact that our last number in this synthetic division table is a 0 is a good thing, because it says there's no remainder. It also likely means you did this process here correctly. So like always, I'll label just so we remember what's what, and I can rewrite the problem as x squared minus 9x plus 20. Now, I'm throwing the equals 0 at the end solely because we're trying to find zeros, aka we are solving. So one of the little trickier parts here is, again, we use synthetic division in some different ways. If I'm just straight up dividing, like we did in the first lesson with this, once I get the x squared minus 9x plus 20, life is good. When we added the factoring, we then broke this apart. Now we are finding all the zeros, which means you are going to factor it and solve for the solutions for x. So that's why we set this equal to 0. From here, you're going to factor this trinomial apart. So x squared minus 9x plus 20. That'll factor apart as x minus 5 and x minus 4. And again, you can see I'm doing a little check here just to make sure it matches up with the middle. Life is good. It's factored correctly. Once you've factored it, now you're going to solve. So this goes back to zero product properties, something we reviewed multiple chapters ago. We're going to go ahead and take each of the little factors and set them equal to 0. And then once we do that, we can go ahead and solve. So we end up with two x values of 5 and 4. Once you have done that, you're at the end of the problem. So again, it's very much a process here, and it takes several steps to work through. But my hope is that you see with the math here, we've done synthetic division multiple times. You've done factoring many times. You've solved from factoring multiple times. It's just taking the math you know and applying it in a different way. To answer the question of what are all the zeros, all we got to do is list out what the answers were. So we had our calculator tell us -1 was an answer, and then the 2 we just got from the factoring, 4 and 5, we list those as well, and that is your final answer. So we're going to go ahead and repeat this process here a couple of times here. So if you want to try one of these problems here on your own, just to make sure you're doing it right and see if you match up with me, great. If not, continue watching here. So number 3 is a pretty similar problem. X cubed minus 8x squared plus 5x plus 14. I'm actually going to go ahead here and enter that in the calculator just so you guys can see it one more time. So we type this in. As I click through some buttons, here we go. Go to our table. So once again, I want to look in the table for a 0. Now once again, the first one I see, -1, 0. Okay, that happens to be a pretty common 0 in some of these problems here. It doesn't always come up, obviously, but that's a common place to pull from. That's the 0 we can use to get started. You also notice there's 2, 0. Eventually, you'll get that as one of your answers as well. It's also one that you could certainly start with if you wanted to. But I'm going to go ahead and use -1, 0 because it's already what I have written out on the screen. So I'm going to use that to get started. We're going to do the same thing as the last problem here. So we're going to use the calculator to get a 0. -1, 0 coming straight from the table. And then we're going to verify with algebra. We're going to use synthetic division to chip this problem apart, whittle it down a little bit, and we're going to go ahead and solve. So once again, I look at my function. There's nothing missing in terms of a placeholder, so this should be an easy setup. Whip off your coefficients with the 0 in the little elbow box. Pull down that first number and continue that multiply and add pattern. You can see how everything's filling in here. Multiply, add, multiply, add, multiply, add. If you do it correctly, once again, you should have a remainder of 0, which we do. And we've got all the other values here that we can label. So I can write this out as x squared minus 9x plus 14. And again, since we're finding zeros, we're finding solutions, we set that equal to 0. So we're going to take this here. We're going to factor it apart. So let's go ahead and factor. The two numbers that we factor this apart with would be x minus 7 and x minus 2. Okay, and you can see here I'm checking that once again with the middles and the outside to make sure that it matches what's in the problem. It does. Life is good. And then we take each of the factors, set them equal to 0. So if I take the x minus 7, that would mean x is 7. If I take the x minus 2, that means x equals 2. Once I factored, again, I've got my answers. I just need to write it out. So I'm going to list my zeros. We have the -1 that we started with from the calculator, and the 2 and the 7 we just got from factoring. And those 3 would be my solutions to this particular problem. So we're going to take a look here at 2 more examples here, just again to keep practicing here. The next one is a little bit, it's the same math, but it's a little bit more involved than what we've done in these past couple of examples here, simply because of the amount of terms that we have to start with. So we're going to go ahead and look at number 4. So we've got our function. So once again, I'm going to type that in. So we have 2x to the 4th minus 9x cubed plus 37x minus 30. So again, we go second graph, get our table. A lot of different things to pull from here. So -2, 0 is the first 0 that I see. Again, there's some other options on the screen, but I'm just going to go ahead and pull that one first. Now, you'll notice one other thing that I've done, okay, that I will go back over here in a second. If you notice in this function, now it has no impact on when you punch it in the calculator, the graph, and pull the table. But when we do the division, there is no squared, okay? It is missing that 0x squared in the middle. You are going to need that placeholder once we get to the synthetic division piece. So if you have to make sure to notice that. Again, you don't necessarily have to do that right off the bat to punch it in the calculator, but you'll certainly need it when we do the synthetic division here in just a moment. So once again, we're going to use our calculator to get that initial 0. So get -2, 0. That's it. Do some synthetic division here. So once again, we're going to verify. The placeholder is important because if you don't have that placeholder in, you're not going to get the correct expression at the bottom. And you'll also notice too that your remainder will be off, which should also be a clue that you're missing something. So again, we do that same pattern with synthetic division. You can see all the terms popping up here. And we end up with a remainder of 0 at the end, which is a good thing. But what's different about this problem is the expression that's left over is a cubic, okay? It's a cubic expression. It has an x cubed. The fact that it is a cubic means I can't just go and straight up factor it to solve it or use another strategy to do some solving. We don't know how to do that, okay? You have to get this down to the point where it is an x squared or lower, okay? And again, x squared will be good enough for you to solve it here. So this is the expression you would have left, okay? Since it's a cubic, okay, you are going to have to repeat this process in order to get it down to something that's quadratic, to something that is squared. So what we're going to do is we're going to go back to the calculator and pull another 0. So if I go back to the table here real quick, 1, 0 was another 0 we can pull. You can go ahead and plug that in and do synthetic division with the expression we just got. So again, I'm just pulling the coefficients from the answer we got from the previous step. And we repeat the process here to get ourselves a quadratic expression. Again, I know I'm in good shape because my remainder was 0. So I'm left with 2x squared minus 11x plus 15. This is now something we can solve by factoring. And you can see here we're going to go ahead and factor. Now you got to be careful because we've got ourselves a situation where it's a 2x squared. So the 2x squared splits apart as 2x and x. You take two numbers and multiply to 15. That'll hopefully work your way to get to -11. And you can see the combination that I picked there. 2x minus 5 and x minus 3 is how you break that apart. You set each of those equal to 0. So you can see with the first factor, it turns into x equals 5 halves. And then with the second factor, you get x equals 3. This one, obviously, they take plenty of steps in the first place, but dealing with the fact that we had something to a 4th power means we had to do multiple waves of synthetic division to get this down far enough to factor and solve at the end. I'm not saying you're going to see billions of problems like this, but ultimately, the higher the power, the higher the degree of the function you're dealing with, the more of these steps you have to do to kind of chip away at it to eventually solve for it. But now that we've factored it, we solved and got those couple of numbers there, we can go ahead and list our final answers here. So the -2 and the 1 that we pulled from the calculator, the 5 halves and the 3 we can pull as well from the factoring we just did. So that would be your final answers there and the zeros of this particular function. We're going to go ahead and do one more example here, and this will be a lot more similar to what we just did in the 2 prior to this. So we've got our expression here. Once again, you can use your calculator to punch stuff in. I'm not going to punch it in at this point. -1, 0, if you punch in that function, will come right from the table. Now this one's a little bit nicer because, again, there's one less term. There's no need for a placeholder. Everything is in order like it's supposed to be. So we're just going to go ahead and do synthetic division and work that through. So same steps as always. Again, we get a remainder of 0, so I know we're in good shape. So you're left with 2x squared plus 3x minus 14. Again, it's another 2x out in front, so we got to take a little more time and factor this correctly. So split apart 2x squared is 2x and x. And try to break apart -14. 7 and -2 would be the right order to do that, as you can see. Checks itself out, so it's factored correctly. So we set 2x plus 7 equal to 0. You solve it. X ends up equaling -7 halves in this case. Then take the x minus 2. Solve for that. You get x equals 2, which will then give you your final list of zeros. -7 halves, -1, and +2. Reason why it's important to be able to do this with the algebra is for these situations here, like number 4 and 5, in that you don't always get integer answers. If they were always integers, you could just go to the calculator and get them all in one shot without any work. But a lot of times you have fractional answers. You'd have to do a lot of adjusting with your table and really messing with that to try to find your different answers. Sometimes the answers are not going to be in that table. So you do have to use the algebra in order to verify and justify the solutions you are getting. So that's how you find zeros. And again, we're using our calculator here to kind of help get us started. But then from there, we're using synthetic division and we're using factoring to solve for everything. In the next lesson, you're going to see a lot more of this. But what you'll also see moving forward is that to solve at the end here, it may not always be factorable. We may have to use our old friend quadratic formula. And we'll see that here in the next lesson coming up. If you have any questions on anything, obviously let me know. Otherwise, thanks for watching.